All right. I think I'm filming. Have I started? Yes, I have. Anyway, while I was filming the last section, my camera died, so I have a lot of it written out already, so I'm just going to go through it again, so that's why half of it's already written down. Section 2.6 is about the rules for multiplication. The previous sections covered addition, subtraction, and the distributive property. Now, this section has several properties, and it's not really important that you know the names of the properties, just what they're meaning. So the first three deal with A, and A stands for any real number, and that's what it says here on the side. The first one, the identity property of multiplication, is pretty simple. It just says if you multiply any real number by a 1, you're going to get the exact same number back. And this is just the commutative version of this. The multiplicative property of 0 says that if you multiply any real number A by 0, you're going to get 0. Multiplicative property of -1 says that if you multiply A by a -1, it's going to change the sign. You're going to get the opposite of A. In other words, it's going to change the sign of whatever A was to start with. If A was positive, it's going to become negative. If A was negative, it's going to become the opposite of that, which is positive. Okay, hopefully my camera won't die again here. The property of opposites and products says for all real numbers A and B, if you look at the first two, one of the numbers is negative. Here, let me zoom in a little bit. I think I lost my focus. One of the two numbers is negative, and so a negative times a positive is a negative product. A positive times a negative is a negative product. But a negative times a negative makes a positive product. Now this next rule is really important. And it's actually 2 rules, but you have to meet this criteria in order for the rules to be true. If it only works if you have an expression that has multiplication and or division. There can't be any addition or subtraction in it. So only an expression that has multiplication or division, and or division. Then the following is true. An even number of negative signs makes a positive answer. So just count the number of negative signs in the expression. An odd number of negative signs, and that's where I got cut off. An odd number of negative signs makes a negative answer. All right, so this is, I'm going to put a box around it. This is the first piece of the rule. All right, and examples would be, I could have -2 times -3 times -1 times -2. So if I add up all the negatives, I have 1, 2, 3, 4. That's an even number, so my answer is going to be positives. So then I don't need to put any sign here, and that's going to give me a 12. And notice that the parentheses are gone once you multiply the numbers out. If I have -5 times -1 times 2 times -1. Counting the negatives, I have 1, 2, 3. That means my answer is going to be negative. Then I just have to multiply the numbers. It's really 5 times 2 is going to be 10. Now, those expressions just have all multiplication, but you could have something like this as well. 3 negative x 1 over negative y times negative 10. So in this case, I have multiplication and division all together, but still there's no addition or subtraction, so the even-odd rule still applies. Just not worrying about the numbers or variables, just counting the signs. I have 1 on the top, 2 on the bottom. That makes 3, which is odd. So my answer is going to be negative, and I'm going to put it out in front of the fraction. Now on the top, I just get a 3 times x, 3x. And on the bottom, I get y times 10 is 10y. I can't simplify that any farther. So notice all the parentheses are gone, and the negative sign, I could have put it up here, out in front, or down below, but I usually like to put it out in front so it's a little more clear. All right, so that's part 1 of this rule. Part 2, flip over here. Part 2, this paper is really see-through, but that's all right. It's not an official rule, but I'm writing it because I find that it's handy to understand this. This won't come into play in the section that you're in here, but down the road it will. The negative signs are free to roam anywhere in the expression. And this is still, you still have to meet the criteria of being only multiplication and division in your expression. You still can't have addition or subtraction for this to be true. So the negative signs are free to roam. I'm going to put that up here. Still only multiplication and or division. And this means, so let's look at some examples. If I had negative 2 times a times b, this is really the same thing as if the negative were on the a. 2 times negative a times b, or the negative could be over here with the b. Sometimes you want to move them around so things are convenient. Or it could be with the b, but these are all basically the same thing. That negative can move around. This might even make more sense. This is something that you might run into sooner. With fractions, you could have a negative sign, let's put the a down here, with a number in the numerator, but that's really the same thing as the negative sign being down here, which is really the same thing as it being kind of out in front of the whole fraction like that. So it doesn't really matter. I have only division here. There's no addition or subtraction, so that negative can move around. Personally, I like it here, out in the front. It's a little less confusing, but anyway, it can be in any of those 3 places. Now, just to work some examples from the book, I think, let's see here. Let me slide up a little bit. I'm going to put another line. So example 1. Negative 3x times negative 4y, and the directions would be to simplify. So this expression has only multiplication in it, so you could either just know that a negative times a negative is a positive, or you could consider this to be 2 negatives, which is even, and you're going to end up with a positive answer. So there's no negatives in my answer. Multiply the number parts together, 3 times 4 is 12, and then stick the variables on, normally in alphabetical order, at the end. All the parentheses are dropped right now, so you get 12xy. Example 2. Let's see, let's do here's 1, -9 times 3 times 0 times -5. Well, I could start looking at the negative signs, but the first thing I'm going to notice here is that I have a 0, and that goes back to this, that if you multiply any real number by 0, it's going to be a 0. So if I were to multiply all three of the numbers, 9 times 3 times 5, and whatever that is, that still has to be multiplied by 0. So anywhere, if there's a 0 anywhere when you're multiplying, the answer is going to be 0. All right, the other types, they're going to mix some distributive property in with this too. So let's do one that has that. We've got -9 times -5y minus 8. Now I'm going to go ahead and do the keep, change, change to make this addition. So I'm going to keep the -5y, change the sign of the last number. Now what I can do is go ahead and multiply, distribute that -9 into both pieces. So -9 times -5y makes, you multiply the numbers, that's positive first of all because they're both negative. It's 45y plus -9 times -8 is a positive 72. Let's do example 4. If I have a -1, and let's make this x minus y minus z. Keep, change, change first. So keep, change, change, keep, change, change. Now, when you multiply a -1 by anything, as seen here, it just changes the sign of whatever that number is. So because I have to distribute this -1 in there, it's just going to change the sign of all of these. It's the same thing as if we did a rule like this in the previous section. If there's a negative sign or a subtraction sign outside the parenthesis, it's the exact same thing as if it were a -1. So these two cases are the same. It just changes the sign of everything on the inside. So this would be -x plus y plus z. And that's what you get. Let's see. Let me see how I'm doing on time here. I'm a little close, but I think I can maybe do one more quick example. Example 5. Doing one that has -y minus 3z. This one is just about adding like terms, but they're throwing in negatives. Or y minus 9z minus y. So just go through, change to addition. So keep, change, change. That one's okay. It's already, don't change the addition. It's fine already. Only the subtraction. Keep, change, change. Keep, change, change. Now look for like terms. Negative y plus a negative y. We're adding. Don't forget, you're not multiplying. Adding, that's negative 2y. And those are finished. We have a negative 3z and a negative 9z. So those two negatives are going to add to a negative 12z. Oops, I forgot the 4y. That 4y is going to add back to this. So let me just write it. I should have combined that with the other 3y's. Anyway, negative 2y plus 4y is going to give me a positive 2y. So I could have done that all in the first step. But you end up with 2y plus negative 12z. All right, that's the end.